Okay, today we're going to talk about how we can add and subtract algebraic fractions. So we're still in that section where the vocabulary is algebraic fraction. This covers the standard, the integrated algebra standard AA17, which is add or subtract fractional expressions with monomials or like binomial denominators. Okay, so first let's review arithmetic fractions. Now with arithmetic fractions, fractions that just have integers in the numerator and denominator, when you have, there's three categories. Arithmetic fractions with like denominators, arithmetic fractions with denominators that share a common factor, and those that have no common factor. So first remember that when you add or subtract fractions that have a like denominator, you just subtract the numerators and keep the denominator. Okay, and this becomes -1/7. Now if they share a common factor, in order to create a like denominator, you don't have to, the smallest common denominator will not just be the product of the two. So here 10 and 15 share a factor of 5, so I can multiply 10 by 3, or that first fraction by 3/3, and the second one by 2/2 to get 30 as a common denominator. Notice that 3 and 2 is less than, so sometimes what people will do is they'll just multiply this by 15/15 and this by 10/10, and then of course you get the common denominator of 150, but then you have to reduce in the end, so don't do that. So here you want to multiply this again by 3/3 and this by 2/2, and then this becomes 12/30 minus 16/30. 12 minus 16 is -4/30. Now -4 and 30 share a factor of 2, so this would become -2/15, and that's as far as you can go. Okay, so the next category of fraction is fractions where the denominators, 7 and 3 in this case, have no common factors. Since 7 and 3 have no common factors, what you can do is multiply this one by 3/3 and this one by 7/7, and this becomes 15/21 plus 56/21, which ends up being, let's see, that's 1, and that becomes a 71/21. Okay, and that's as far as you can go. One quick note about this type of fraction, and only the third type of fraction, is, if this is a quick way to do it, A/B minus C/D, and this is where the denominators B and D have a GC, well, let me write it this way. The GCF of B and D is 1. It's where the GCF, the greatest common factor between B and D, is equal to 1. What you can do is you can multiply the numerator of the first one times the denominator of the second one. That's AD minus, and you can multiply the numerator of the second one times the denominator of the first one, minus CB, and that's going to be all over B times D, the product of the two. So let's redo that. So write that in your notes. So let's redo that, and we should be able to get 71/21. So in this case, this would be 3 times 5 is 15. We had a plus in ours, so we'll do the plus and the minus. It's either this one, or you can use the minus if they were actually being subtracted. So 1 times 3 is 15, plus 7 times 8 is 56, all over 7 times 3 is 21, and recall that's what we had right there. Okay, so that's a quick way to do only type 3. Okay. All right, so let's go through arithmetic fractions. We're going to have the same three categories, ones that have the same denominator. If they have the same denominator, then what you can do is just subtract the numerators, but recall that when you subtract, you have to subtract that whole binomial. So we have 3x squared minus 7x minus 8x minus 3 all over 2x. Okay. Now there's a protocol for subtracting binomials. That protocol is adding a 1 in front, doing KCC. So we have 3x squared minus 7x plus -1 times 8x minus 3 over 2x, and then distributing. Okay, so we have 3x squared minus 7x plus -8x and that's plus 3, because negative 1 times negative 3 is positive 3, all over 2x. Now let's clean up the top a little bit, and we should be done. Okay, so these are like terms. Negative 7x plus negative 8x is negative 15. So we have 3x squared minus 15x plus 3 all over 2x. Okay, and if you wanted to, you could factor a 3 out of the numerator to get 3x squared minus 5x plus 1 over 2x. Now, the 3 up there does not cancel with anything down here. Let's see the factors. If I put the trinomial into an x factor, I wouldn't, let's see, nothing multiplies to 5 and adds, multiplies to 1 and adds to 5. So there's no more factoring I can do here. That is the end result. Okay? I'll also accept this as well. Okay, now we have type 2, factors that share denominators that have a common factor. So the GCF between a squared b and ab squared is going to be ab. Okay, so I only say that to note that we don't have to multiply the fractions by the denominator of the other fraction. Now, what is my lowest common multiple between a squared b and ab squared? That's the smallest number that has both these things as a factor. Well, this has an a squared in it, so I'm going to need an a squared. This one has a b, and that one has a b squared, so you want to keep this as b squared. So the lowest common denominator here is going to be a squared b. That means I need to multiply this one by b over b. I need to multiply this one by a over a. So I'm left with 5b over a squared b squared plus 2a over a squared b squared. Notice now they have the same denominator, okay? And I can have this, so this is equal to 5b plus 2a all over a squared b squared. And there's nothing else I can do here, right? I can't cancel the b in the numerator with that in the denominator because the b in the numerator is part of an addend. Likewise with the a in the numerator. Sorry, the b in the numerator is an addend. The b in the bottom is a factor because it's being multiplied by the a squared. But since the b in the numerator is not a common factor, I can't cancel it. Okay, for this next one, I say that these two denominators have a common factor because if you factored x squared minus 4 into common factors, you would have, so we have 6x over, now this is x minus 2 and x plus 2. Minus 3 over x minus 2. So these are the two things I'm trying to subtract. Now if you notice, this has an x minus 2 and x plus 2, and this only has an x plus 2. So if I multiplied the second fraction by x plus 2 over x plus 2, I'm going to get the common denominator of x minus 2, x plus 2. So I would have, okay, I'd have 6x over x minus 2, x plus 2, minus 3 times x plus 2 over x minus 2, x plus 2. Now, since I have common denominators, I can just add together. My common denominator is going to be this. My numerator is going to be 6x minus 3 times x plus 2. Now I'm going to have to go and use KCC and then distribute, so plus a negative. I'm going to distribute negative 3 in. So if I do that, I'm going to get 6x plus negative 3x plus negative 6 all over x minus 2, x plus 2. And then the 6x and the negative 3x, that's just going to be 3x. And I'm going to put this as minus 6 all over x minus 2, x plus 2. And the final thing is to ask yourself whether you can cancel anything. Now the numerator actually has a way that we can factor it. 3 is a GCF, so I can go 3 and then I have x minus 2 remaining. And on the bottom, since I have an x minus 2 and an x plus 2, one of those cancels. So the last thing that I have here, my final answer, is 3 over x plus 2. Okay? Now finally we get to the third type of algebraic fractions, those with no common factor. Now these actually turn out to be a little easier because what we can do, we can use that a over b minus c over d is the same thing as ad minus bc over bd. Okay? Remember, we could change this to a plus if we wanted to, so I'm going to put this in blue, and that would change to a plus. Okay, since 3a and 2b, and I stress, you cannot use this if you have factors that have like denominators, or denominators with a common factor in them. It's just going to make your life a lot harder if you try to use this shortcut. But since 3a and 2b do not share a common factor, the trick is to multiply this times this. So I'd have 2a squared minus 3. And you know what, I'm going to put the monomial first. So I'm going to put 2b minus 2a squared minus 3 minus, now I'll do 3a times 5a. And that's all over the product of these two, which is 3a times 2a. Okay? So next step is to multiply on the top. And I'm going to do keep change change right there. So I have 2, that would be 4a squared b. It's traditional to put the variables in alphabetical order, so that's that product. And then I have minus 6b plus, and that's a negative 15a squared. Okay. And on the bottom I have 6a squared. Okay. Now on the top, let's see. On the top, I can't factor out a 2. Can't factor out an a squared. So there's nothing I can really factor. Even though 2 is a common factor between 4, 6, and this 6 right here, it's not a factor here, so I can't factor it out of the numerator to cancel with it in the denominator. So this is as far as I can go with this one. And again, even though this term, and this term have an a squared, this one doesn't have an a squared. So I can't do anything there. Yep, that's it. Okay, so going on to the next one. Again, 3 and 4 don't share a common factor, so I can just do 4 times 2x plus 5 minus 3 times x minus 2 all over the product of 3 and 4. Okay, I'm going to do keep change change here, so I'm going to change this. Now I have, I'm going to distribute. I have 8x plus 20 plus negative 3x, and this ends up being, so plus 6, okay, over 12. Let's clean this up a little bit. These two are the same, so, or they're like, so I have 5x. Let's see. I have 5x, and then 20 and 6 is 26 over 12. Okay, and again, 26 and 12 share a factor of 2, but 5 doesn't share that factor. 5 has an x and nothing else has an x, so there's nothing else to factor. Okay, I'm going to do a few more. Make sure you write these in your notes. Okay, so the first thing to do is identify which type of algebraic fraction it is. This is type 1, where they have the common denominator. So I can just do 5r minus 2s all over t, and there's nothing that I can factor out and cancel, so that is as far as it goes. This also has a common factor of 4y plus 3, so that's going to be the shared denominator. So I have 6y minus 4 plus, now I don't need to use parentheses because I'm not subtracting, so I can just put them all together and then simplify. I have 4y plus 3 all over 4y plus 3, and those cancel out to get 1. Okay. Now here, I'm adding 3 terms, so I want to think about the common denominator between all 3 terms. So the lowest common multiple between 2x, x, and 8x, let's think about this, is going to be 8x. Okay, so 8x I don't have to do anything with. This one I'm going to have to multiply by 8 over 8. And this one I want to multiply by 4 over 4. Okay, so I would get, let's see, I get 4 over 8x minus 8 over 8x plus 1 over 8x, and that's going to be 4 minus 8 plus 1 all over 8x, and 4 minus 8 is negative 4 plus 1 is negative 3 over 8x. That is as far as I can go. Okay, just 2 more. All right, the next one has, let's see, it actually shares a common factor. If I factored this right here, so let me keep the first one the same, and let's factor the second one. If I factored a 5 out, I'd have 3a minus 1 right here. So really the difference between the first fraction and the second one is that this one has a 5 and this one doesn't. So I'm going to multiply that by 5 over 5. I'd have 10. And I'd really only be able to see that if I had factored that second fraction. So I have 10 and 5 times 3a minus 1 plus 7, 7 times 7 over 5 times 3a minus 1. And that gets me, if I add those two together, I get 17 and 5, 3a minus 1. And there's nothing that will cancel there. That's finished. Okay. This last one, okay, I'm going to, first thing I want to do is I want to factor them. Okay, so the top doesn't factor here. There's no GCF there. The bottom I can factor a 3 out, so I have x plus 4y. Now the top of the next one doesn't factor in anyways. And the bottom, let's just see how this factors. Okay, I'd have an x here, an x here, and I'd have something with a y here and something with a y here. Now let's look at the numbers in here. I have 3 and negative 4. I want something that factors, that multiplies to negative 4 and adds to 3. So that would be negative 4 and, nope, it would be 4 and negative 1. So if I put this as negative 1x and positive 4y, I should get my factors. Okay, so that bottom there is going to be factored like that. So I have 3 times x plus 4y, and I still have, I'm going to put a little arrow. Okay, and this is also being multiplied by x minus 1y, or x minus y. Okay, now when I multiply those out, I would get, so now, well, so the second fraction has this x minus y. So the first fraction I have to multiply it by x minus y in the numerator and the denominator. So the first one is going to be, I'm going to bring them all the way up here, x plus 2y times x minus y. And the numerator of the second one is going to be plus 6. I don't have to do anything to it. And the common denominator is going to be 3x plus 4y and x minus y. I changed the x minus 1y to x minus y. Okay, now let's FOIL out these two to simplify them. Okay, so the first would be x squared minus xy plus 2xy minus 2y squared. Okay, and on the numerator, I'm just going to add them down here. I have still 6x minus y. The numerator, let's just keep that the same. Okay, and let's clean up the denominator a little bit. Actually, the denominator doesn't really clean up that well. I have these two are like, right? So I just still have an x squared. I'd have a plus xy. Then I'd have a plus 6x, a minus y, and a minus 2y squared. And the bottom I have just this complicated thing right here. Okay, and that's as far as you need to go with this. And it was a little bit complicated, so make sure you pause it and understand every step of it. Okay, or come in with questions tomorrow if you have questions. Okay, and that's the last example. So you were taught how to add and subtract algebraic fractions today by by classifying them into three different classifications: those with like denominators, those with denominators that share a common factor, and those that have no common factor.